Okay, Math 9, here we go. We got a video on polynomials. This is your introduction to polynomials. You've seen similar to this before, but we're going to start by doing a little bit of vocabulary. So I've said the word term a lot when we were doing algebra, but let's get a little bit clear on what a term is. A term is, the definition is any coefficient, so any number, so 5 is a term, -2 is a term, right? Any variable, so x is a term, y is a term on their own, and then or a product of any of those together. Product means multiplication. So 5x is a term, -2y is a term, x, y, z is a term, x squared, y, z cubed is a term. All these are combinations of variables or numbers being multiplied together. Those are all terms, okay? And now what are like terms? Well, like terms are terms that are the same. They have the same variable to the same exponent. So like terms like 5, 2, 3, -4, those are all like terms because they're all just numbers. 5x, 2x, -3x, -4x, those are all like terms because they're all x terms. Now those we saw in algebra. But then here, like 2x squared, 5x squared, -4x squared, those are all like terms as well because they have the same variable, the same power. If you had 2x squared y and 3xy squared, those are not the same because they have different variables, well, same variables, but they're to different powers. So everything needs to be exactly the same. So in order for those to be like terms, it can't be xy squared, it would have to be, again, x squared y. So that is what a like term is, and you can combine like terms. It's like the apples and apples, oranges and oranges. What is the degree of a term? So if you look at a term, so I'll just write a few down. There we go. Okay, the degree of a term is the whole number of the exponent of the term. Or if there's multiple exponents, you have to add all the exponents of the variables only together. So here, I have no variables. So my degree is 0. Here I have an x to the power of 1, so my degree is 1. Here I have an x to the power of 2, so my degree is 2. Here I have 3 different variables, so I have to add up all of their powers, all of their exponents. In this case, it's just 1, 1, 1, so this is a degree 3. And here I have 2, a 1, and a 1, so that is a degree 4 polynomial. So it is the total of the exponents on the variables. Now, if I gave you this and you were like, oh, that's degree 2, we'd say no, it is not, because that is not the exponent on a variable, because that is just 25. Now there's no power anymore, right? So it only matters the exponent on the variables, all right? So that is the degree of a term. So what then is a polynomial? Well, a polynomial is just a collection of terms using addition or subtraction. So x plus 5, that's a polynomial. 2x squared minus x minus 4, that's a polynomial. 4x squared y plus 2, that's a polynomial. So poly means many, and then nomial means term. So yeah, there are special names for some of these, but we won't worry about that this year. You'll look at that in depth in grade 10, but these are all what we call polynomials. The only thing that is not allowed is you cannot have an exponent that is a negative number or an exponent that is a fraction. If you have that, it technically is not a polynomial, but in all of these it is, okay? So what is the degree then of a polynomial? So let's write down a polynomial. So here x plus 4, here x squared plus 2x plus 7, and here we'll go x, y, z plus x, y squared z minus x squared, y squared, z squared, just for fun. So the degree of a polynomial is the highest degree term. So whatever the highest degree term is, that is the degree of the entire polynomial. So here we have a degree 1 and a degree 0. So this is a first degree polynomial. Here we have degree 2, degree 1, degree 0. So that is a second degree polynomial. You don't add all the degrees together, it's just whatever the biggest one is. So this here, 3 different variables, right? So that's a degree 3, that's a degree 4, that's a degree 6. So that would be a 6th degree polynomial. You just take whatever the highest degree term is, and that is your polynomial. So what does it mean then to be in descending order? Well, you think about descending, it means top to bottom. So if you have a polynomial written like this, you need to identify the degree of each term. Well, okay, so this is a degree 2, this is a degree 0, this is a degree 1. And what you need to do is you need to rearrange these so that it goes highest to lowest degree. And remember that the sign in front of a number belongs to it. So what we have is we have x squared plus 3x plus 4. And now it's in descending order, 2, 1, 0. I'm going to erase that. I'm going to do another one for you. Okay? So here's another one. What if you have x squared y plus 2x cubed y minus 3y to the power of 2? Well, here we have a degree 3, here we have a degree 4, and here we have a degree 2. So what's coming first? This term. So it's going to be 2x cubed y, and then plus x squared y, and then minus 3y squared. It is in descending order. All right, so top to bottom. Now you're going to see a few instances maybe in these. Let me have a quick scan. Yeah, we'll see some so we can talk about it. So now combining like terms with polynomials is exactly the same as combining like terms for algebra, except we have different degreed terms. So here, it's like, okay, I'm going to get 3q squared minus 2q squared. Well, that's just q squared. Here I have negative 4 minus 8 is negative 12, and then plus 2q plus 4q is plus 6q. So I've combined my like terms just like I did in algebra, and then I want to put my answer in descending order. So this is a degree 2, this is a degree 0, and this is a degree 1. So I just got to rearrange so that I have q squared plus 6q minus 12. Now, descending order isn't necessary, but it's very helpful, particularly as we get to more complicated things and working with them in the future. So here's another one, and here a bit of a curveball, but I'd throw this so we can look at it. Here you have a 5xy. Do you have any other xy statements? Well, this looks close. It's a yx. But remember in multiplication that 2 times 3 is the same as 3 times 2. So you can just rearrange the yx. It's the same as saying xy. So we have 1xy. And then you have 5x squared minus 3x squared is 2x squared. And then you have plus 2x, well, that's plus 4x. And then minus 6 plus 6, well, that just cancels out. So now here we have 3 terms. We have degree 2, we have degree 2, we have degree 1. So now you're like, wait a minute, this is the first time I've seen the same degree twice, and you aren't wrong. So what we do when we have the same degree is we put it in alphabetical order. And you have an xy, and x squared is, right, x squared is technically x times x. So xx comes before xy, so we go 2x squared plus xy plus 4x, and that is technically in descending order. So that's your introduction to polynomials. In grade 9, we're just going to work briefly with them. Next video, we're going to add and subtract them together. This ties into section 6.1, and the notes are quite detailed there, but this first section is really all about vocabulary. So lock that down, get as confident as you can. Awesome.